Types of corrosion inhibitors and their applications. Corrosion is a natural process that occurs when a metal reacts with the environment to form an unwanted compound. This can lead to the degradation of metal structures and the eventual failure of CRIT. ICAL infrastructure. To combat corrosion, many industries use corrosion inhibitors. A corrosion inhibitor is a substance that, when added to an environment, reduces the rate at which corrosion occurs. On metal surfaces. There are several types of corrosion inhibitors, each with its own unique properties and applications. 1. Organic inhibitors. Organic inhibitors are compounds that contain carbon atoms. These are commonly used in the oil and gas industry, as well as in automotive and aerospace applications. Organic inhibitors work by adsorb ing onto the metal surface, forming a protective barrier against corrosive agents. This type of inhibitor is effective in environments with high temperatures and high pressures. 2. Inorganic inhibitors. Inorganic inhibitors are compounds that do not contain carbon atoms. These inhibitors are commonly used in cooling systems, power generation, and water treatment applications. Inorganic inhibitors RK by dissolving in water to form a protective film on the metal surface, preventing the formation of corrosion. 3. Cathodic inhibitors. Cathodic inhibitors work by reducing the amount of oxygen or other oxidizing agents that come into contact with the metal surface. These inhibitors are commonly used in underground pipelines and tank. Cathodic inhibitors work best in environments where the corrosive agents are oxygen or other oxidizing agents. 4. Anodic inhibitors. Anodic inhibitors work by increasing the resistance of the metal surface to oxidative corrosion. These inhibitors are commonly used in acidic environments. Anodic inhibitors work best in environments where the corrosive agents are acidic. 5. Mixed inhibitors. Mixed inhibitors are a combination of both cathodic and anodic inhibitors. These inhibitors offer dual protection against corrosion, making them ideal for highly corrosive environments. Mixed inhibitors are commonly used in the oil and gas industry, as well as in power generation and water treatment. 6. Volatile corrosion inhibitors, VCIs. VCIs are a type of inhibitor that works by vaporizing and forming a protective layer on the metal surface. These inhibitors are commonly used in shipping and storage applications, as well as in manufacturing and military equipment. VCIs are particularly effective in providing long-term protection against corrosion. Each type of corrosion inhibitor has its own unique properties and applications. By understanding the strengths and limitations of each type, industries can choose the most appropriate inhibitor for their specific needs. Ultimately, the use of corrosion inhibitors can help to extend the life of metal structures, reduce maintenance costs, and prevent critical infrastructure failures. In the oil and gas industry, organic inhibitors are commonly used to protect metal structures from the corrosive effects of oilfield brines. Organic inhibitors are effective in high temperature and high pressure applications, making them ideal for use in deepwater wells and high pressure reservoirs. Organic inhibitors work by forming a protective barrier on the metal surface, preventing the formation of corrosion. In the automotive industry, organic inhibitors are often used to protect automotive parts from the corrosive effects of road salt. Road salt can be highly corrosive, causing significant damage to vehicle undercarriages. By adding organic inhibitors to automotive coatings, manufacturers can provide increased corrosion protection and extend the life of vehicle parts. In the aerospace industry, organic inhibitors are commonly used to protect aircraft parts from the corrosive effects of the atmosphere. The atmosphere at high altitudes is highly corrosive, and aircraft parts can be subjected to harsh environmental conditions. By adding organic inhibitors to aircraft coatings, manufacturers can provide increased corrosion protection and extend the life of critical aircraft parts. In the cooling systems industry, inorganic inhibitors are commonly used to protect metal components from the corrosive effects of water. Inorganic inhibitors work by dissolving in water to form a protective film on the metal surface, preventing the formation of corrosion. In the water treatment industry, inorganic inhibitors are commonly used to protect metal components from the corrosive effects of water. Inorganic inhibitors work by dissolving in water to form a protective film on the metal surface, preventing the formation of corrosion. In underground pipelines and tanks, cathodic inhibitors are commonly used to protect metal components from the corrosive effects of oxygen and other oxidizing agents. Cathodic inhibitors work by reducing the amount of oxygen or other oxidizing agents that come into contact with a metal surface, preventing the formation of corrosion. In underground pipelines and tanks, cathodic inhibitors are particularly effective in preventing corrosion caused by soil and groundwater. In acidic environments, anodic inhibitors are commonly used to protect metal components from the corrosive effects of acid. Anodic inhibitors work by increasing the resistance of the metal surface to oxidative corrosion. Anodic inhibitors are particularly effective in preventing corrosion caused by acidic cleaning agents and chemical processes. In highly corrosive environments, mixed inhibitors are commonly used to provide dual protection against corrosion. Mixed inhibitors are a combination of both cathodic and anodic inhibitors, offering a highly effective method of protection. Mixed inhibitors are commonly used in the oil and gas industry, power generation, and water treatment, where highly corrosive environments are common. In shipping and storage applications, shees are commonly used to provide long-term protection against corrosion. Shees work by vaporizing and forming a protective layer on the metal surface, preventing the formation of corrosion. Shees are particularly effective in preventing corrosion caused by salt, air, humidity, and other environmental factors. Proper application of corrosion inhibitors is essential to ensure their effectiveness and to prevent further damage to metal structures. Furthermore, research into new and innovative corrosion inhibitors is ongoing to address the ever-evolving needs of different industries. Nanotechnology-based corrosion inhibitors, for example, show promise in providing enhanced protection against corrosion while minimizing environmental impact. Despite the use of corrosion inhibitors, it's still essential to regularly inspect and maintain metal structures to ensure their longevity. Corrosion can still occur even with the use of inhibitors. And early detection and repair are crucial in preventing catastrophic failures. In addition to using corrosion inhibitors, industries can also take other preventative measures to minimize the risk of corrosion. This includes proper material selection, surface preparation, and application of protective coatings. By implementing a comprehensive corrosion prevention plan, industries can ensure the safe and reliable operation of critical infrastructure. Industries must work towards minimizing the need for frequent replacement or repair of metal structures. This can be achieved by adopting environmentally friendly corrosion inhibitors. The use of Inhibitors that contain harmful substances can lead to their accumulation in the environment, causing harm to both humans and marine life. Industries must take the lead in adopting sustainable practices that can not only lead to an efficient infrastructure but also reduce the carbon footprint. Moreover, industries must invest in extensive research to identify the latest corrosion inhibitors that are both effective and cost-efficient. Innovation in corrosion inhibitors is bound to reshape heat corrosion prevention field. Additionally, industries must embrace collaboration for an efficient preservation process by openly sharing research findings, cases, and successful practices. It is vital to note that corrosion prevention is not the ultimate solution to the longevity of metal structures but rather a primary control measure in curbing the rate of degradation. Regular inspect, tie-in and maintenance of metal structures is essential. The consequences of corrosion can be devastating, leading to significant economic losses, environmental damage, and even loss of life. Therefore, the use of efficient corrosion inhibitors is essential.